This example comes out of 11.3, the binomial theorem. We're asked to find the middle term in the expansion of 4x squared plus 3y to the sixth. This is, again, as soon as you see it's a binomial expansion question, I'd suggest writing down that if you have x plus y to the n, that t term k plus 1 is equal to n choose k, x to the n minus k, y to the k. Now in this question, what do I know so far? I know that n equals 6. It's just the exponent in the expansion. I know that instead of x, we're going to use 4x squared, and instead of y, we're going to use 3y. But what I don't know right off the top is what k is for the middle term. I do need to realize that this would have 7 terms. Remember that the number of terms is always 1 more than n. It's always 1 more than whatever that power is there. So if I have term 1, 2, 3, 4, 5, 6, 7, which one's the middle? It's term 4. So I'm looking here for term 4. They could have just asked for term 4 directly. Sometimes they'll try to be a little cryptic with it like this. So looking for term 4, it means that k equals 3. Remember that k plus 1 is term 4. So if k plus 1 equals 4, k must be 3. So from there it just becomes straight substitution. I'm going to say, well, term 3 plus 1 equals term 4, which equals 6 choose 3 times 4x squared to the 6 minus 3 times 3y to the 3. So then just becomes a little bit of number crunching there to say what is 6 choose 3, and that equals 20. Then we have 4 to the 3, which is 64, x squared to the 3, which is x to the 6th, 3 to the 3, which is 27, and y to the 3. So 20 times 64 times 27, it's a pretty big number, and everything turns out to be positive, which makes sense. So all positive numbers, 34,560, 60, x to the 6th, y to the 3rd. It would be the middle term of that expansion. Notice there's no reason for us to find the first 3 terms or the last 3 terms. We're just asked for one term, and that's the convenient thing about that binomial theorem, is that you can find one term directly like that. Second example here, I'm asked to find the constant term of the expansion of 2x minus 7 over x squared to the exponent 9. Now first of all, we need to know what a constant term is. That's a term where the x's are going to cancel out. In other words, you're going to have x to the 0. You're just going to end up with a number being a constant, whereas if you have a variable like an x or a y involved, it's not constant. So we're looking for the term that has an x to the 0. That's another way of asking this question. I've taught 2 different ways of trying to find this, and they are a little different from each other. First of all, if we're doing using the formula, we know that n equals 9. K, we're not sure about k. Instead of x, we're going to use 2x. Instead of y, we're going to use negative 7 over x squared. So any term in this expansion is going to be tk plus 1 equals 9 choose k, 2x to the 9 minus k, and negative 7 over x squared to the k. Now, there is an algebraic method of figuring out what k is that'll allow me to end up with an x to the 0 term, and I'll show you that in a second. What I would do here, though, is a little bit different, and that is, if you've recognized some of the patterns in the previous expansions, you'll know that the first term of this expansion is going to, regardless of what the numbers are at the front, 9 choose 0, 9 choose 1, 9 choose 2, but in terms of powers of x, you're going to get an x to the 9 term on the first one, and a 1 over x squared to the 0, which will give me altogether x to the 9. And again, I've ignored all the numbers intentionally, the 2, the 7, the negative, and any combinations out front. So definitely that's term 1, and that's not the term I'm looking for because it's got an x to the 9. The next term would have x to the 8 times 1 over x squared to the 1. Well, if you put that together, you get x to the 6 for term 2, and that's not what I'm looking for either. The next term would have x to the 7 times 1 over x squared to the 2, and if you try that out, you get x to the 3. Not what I'm looking for either, but definitely heading in the right direction. And if I look at this next term, it's going to have an x to the 6, it's going to have 1 over x squared cubed, which does give me x to the 0. So it is term 4 that I'm looking for. And so, I could go and find term 4. The other way of doing this would be to realize again that if I break this equation down into its simplest parts and say, well, what's going on with the x's? I've got x to the 9 minus k times 1 over x squared to the k. Again, ignoring this 9, choose whatever, and any numbers, 2s and 7s. Here, I've got x to the 9 minus k times x to the negative 2k. So x to the 9 minus 3k has to equal x to the 0. And what you'll discover is that k has to equal 3, which is what we found down here when we said we need to find term 4, which means k equals 3. So if I go back to my tk plus 1 business, I'm going to say term 3 plus 1 equals 9 choose 3, 2x to the 9 minus 3, negative 7 over x squared to the 3. Now, if I solve that, I do have to do a little bit of numbers. 9 choose 3 is 84. 84 times 2 to the 6, which is 64, x to the 6, and then negative 7 to the 3 is negative 343, but the good news is it's over x to the 6, and those x to the 6's cancel each other out, so I'm just going to have a big negative number here, which is negative 1,843,968. That number itself not super important, but the fact is being able to figure out which term is it that ends up canceling out my x's was the trick here, and that is a tough question, probably the hardest binomial theorem type of question that you'll see in Math 30.